students, I hope all of you are doing good. Let's start today's chapter, Algebraic Expressions. In the previous class, we have learned about the addition and subtraction of algebraic expressions. In this chapter, we shall study the multiplication of algebraic expressions in the form of monomials, binomials, etc. and their application in solving problems. We shall also learn how to factorize algebraic expressions. Now, let us briefly review some of the concepts and definitions we have learned in the previous class. Constants and variables. In algebra, normally we have two kinds of symbols, constant and variables. A constant is a symbol having a fixed numerical value. A symbol having no fixed numerical value and which can take various numerical values is called a variable. Example. We express the perimeter of a rectangle as P is equals to 2L plus B. Here P, L and B are variables while 2 is a constant. Algebraic expressions, a number of combination of numbers, constants and variables connected by the signs of fundamental operations of addition, subtraction, multiplication and division is called an algebraic expression. The different parts of an algebraic expression which are separated by plus or minus sign are called the terms of the expression. For example, 4x square minus 4xy plus 5y square is an algebraic expression consisting of how many terms? 3 terms. Term 1, term 2 and term 3. Okay. Now, this expression has 4 terms. 1, 2, 3 and 4. Right. Monomial. An algebraic expression having only one term is called a monomial. Thus, expression 6 or 2x or 4xy or 2 by 5 xyz, these are monomials. Binomials, an algebraic expression containing two terms is called a binomial. This expression 4 minus 2x, 1, 2. These are the two terms, so it is a binomial, right? Trinomials, an algebraic expression consisting or containing 3 terms is called a trinomial. For example, all these expressions are trinomials. Factors. When two more numbers, constant and variables, are multiplied, then each of them and their product is known as a factors of the product. A constant factor is known as a numerical factor, while a variable factor is known as a literal factor. In a product of numbers and variables, any of the factors is called the coefficient of the product of other factors. Okay. For example, in 16xyz, 16xyz. Okay. See, your 16xy is the coefficient of what? Coefficient of z. Okay. And 16xyz here, and the 16xz means 16xz is the coefficient of what? Coefficient of y, and 16yz is the coefficient of what? X, right? Constant term. An algebraic expression having no literal factor is known as a constant term. Thus, in the expression ax plus by plus cz minus 8, the constant term is what? Minus 8. Like terms. Terms having same literal factors but with different numerical coefficient are called like terms. Unlike terms, terms having different literal factors or different degree of literal factors are known as unlike terms. For example, in the expression this one, clearly x square and minus 4x square, these are the like terms, while minus 2xy and y square, these are not like terms, these are unlike terms, means these terms are not similar, right? Next, degree of a polynomial. The degree of a polynomial of one variable is the highest power of the variable. If the polynomial has more than one variable and every term has its own degree, then the degree of a term is the sum of the powers of its variables, and the highest degree obtained is the degree of the polynomial. For example, in this expression, the degree of the expression is 4 as it is the highest power in all terms of the polynomial. Okay, see, this is x raised to the power 4, right? That is why 4 is at the highest power. Okay, addition and subtraction of algebraic expression. To add algebraic expressions, we collect and add like terms. The sum of several like terms is another like term, whose coefficient is the sum of the coefficients of those like terms. We cannot add the coefficients of unlike terms. In order to subtract an algebraic expression from another, we change the signs from plus to minus or minus to plus as the case may be of all the terms of the expression which is to be subtracted, and then the two expressions are added. Following example will illustrate the procedure. Okay, so we have to add these. Okay, so first what will you do? See, we have to add, first step is we collect or we gather all the like terms. Okay, so we have to add 3x square minus 5x plus 7x. So we have to add minus 8x square plus 4x minus 3 and plus 11x square plus 7x plus 8. Okay, so first let's open the bracket, and after that we will collect all the like terms, plus 11x square plus 7x plus 8. Okay, now let's collect the like terms. X square, 3x square minus 8x square plus 11x square. Okay. Okay, now x. In bracket, what will you write? Minus 5x plus 4x plus 7x. Okay, now write the remaining terms, means constant. 7 minus 3 plus 8 plus 7 minus 3 plus 8. Now solve. 11 plus 3, 14, and 14 minus 8 is 6x square. Okay, 7 plus 4, 11, 11 minus 5 is what? Plus 6x. Okay, and 7 plus 8, 15, 15 minus 3 is 12. So 6x square plus 6x plus 12 is the answer, right? Exercise 14.1. Classify the following into monomials, binomials and trinomials. How many terms are there? 1, 2. So this is what? Binomial. Okay. How many terms are there? Only one. So this term is monomial expression. Okay. Now, multiplication of algebraic expression. While multiplying algebraic expression, we shall be using the following rules of signs. Number 1. The product of two factors with like signs is positive and the product of two factors with unlike sign is negative. Thus, we have plus into plus, plus, plus into minus, minus, minus into plus, minus, and minus into minus is plus. Okay. So, if A is any variable and m and r positive integers, then a raised to the power m into a raised to the power n is equals to a raised to the power m plus n. Okay, and similarly a raised to the power 6 into a raised to the power 6 is what? A raised to the power 3 plus 6, that is a raised to the power 9, right? Next, multiplication of two monomials. Multiplication of one monomial with another monomial is the simplest form of multiplication. The coefficient of the product of two monomials is equal to the product of their coefficients, and the variable parts in the product is equal to the product of the variables in the given monomials. Example, multiply 2x square y cube and 7xy square. Okay, so we will multiply 7, 2 and 7, then x cube into x, y cube into y square. So the answer is 7 into 2 is 14, x power 3 plus 1 4 and y 3 plus 2 5. So this is the answer. Okay. Now multiplication of a monomial and a binomial. To multiply a binomial by a monomial, the distributive property of multiplication over addition is handy for us. We know that if p, q and r are three monomials, then p into q plus r is what? P into q plus p into r, and in case of subtraction, p into q minus p into r. Okay. Example is 5x. Okay, let's first rub this. 5x minus 2 by 3 xy square by 1 by 7 xy. Okay. So what will we do? First you will multiply this by this. 5 into x, 5x into 1 by 7 xy. then minus 2 by 3xy square into 1 by 7xy, okay, 5 by 7x square y, then minus, write in bracket, minus 2 into 1 is 2, 3 into 7 is 21, x square y cube, okay, 5 by 7 x square y minus 2 by 21 x square y cube, okay. So this method is known as horizontal method, and there is column method also, okay. So the column method of multiplication is also known as vertical method of multiplication, right. Exercise 14.2, find the products. 2x square into 9x square. First multiply numericals, that is numbers, and x square into x square. 2 into 9 is 18, x raised to the power 4. So 18 x raised to the power 4 is the answer, okay. Multiplication of two binomials. To multiply a binomial by another binomial, we can conveniently use the distributive property of multiplication of literals over addition. It is explained below. Let there be two binomials, say a plus b and c plus d. Using the distributive property of multiplication of literals over their addition, we have a into b into c plus d. Now what will you do? You will first multiply a into c plus d, then plus b into c plus d, right. Now a into c plus a into d, then plus b into c plus b into d, okay. Now let's do the example. We have to multiply binomial by a binomial. 4x plus 5y into 2x plus 7y. Okay. First we will multiply this expression by 4x. 2x plus 7y. Then there is a plus 5y. 2x plus 7y. 4 2s are 8. 8x square plus 4 7s are 28xy plus 5 2s are 10xy plus 5 7s are 35y square. 8x square. 28 plus 10 is 38xy plus 35y square, okay. Multiplication of a binomial and a trinomial. Now the distributive property of multiplication over addition of literal can be extended of trinomials and to all algebraic expressions containing any number of terms, okay. Let's do the example. Example is we have to multiply 2x square minus 4x plus 2 by 7x minus 3, okay. So how you gonna do it? 2x square multiply 7x minus 3 minus 4x 7x minus 3 plus 2 7x minus 3. 2 into 7 is 14, x cube minus 2 3s are 6x square, okay. Now minus in bracket 4 into 7 28x square minus 12x plus 2 into 7 is 14x minus 6, 14x cube minus 6x square. Now there is a negative sign before the brackets, so all signs will change. Minus 28x square plus 12x plus 14x minus 6, okay. 14x cube. 28 plus 6 is what? Minus 34x square. 12x and 14x is what? 26x minus 6. So this is your answer, okay. So students, similarly you will do this example also. Now let's do exercise 14.3. Multiply the following. 2x plus 4 and by 6x plus 5. 2x, 6x plus 5 plus 4 and multiply by 6x plus 5. 2 into 6 is 12x square plus 2 5s are 10 plus x. 4 6 are 24 plus x, 24x not plus, plus 4 5s are 20. 12x square, 10 plus 24 is a 34x plus 20. Okay, so this is the answer, right? Standard identities, that is some special products. An identity is an equality which is true for all values of the variable. An identity implies that the expression on either side of the equality sign are identical, means the same. We shall consider 3 standard identities that are helpful in solving problems involving algebraic expressions. Okay. Identity 1 is a plus b whole square is equals to a square plus 2ab plus b square, or you can also write it like a square plus b square plus 2ab. Okay. This means that the square of the sum of 2 terms is equals to square of first term plus a square of second term plus 2 into first term into second term. Okay. So, how are you going to prove this? See, a plus b square is equals to, you can write it as like a plus b into a plus b, right? Now, a will multiply this by a, then b, a plus b, a square plus ab plus ab plus b square. So, a square plus 2ab plus b square. Okay. Or you can also write it like a square plus b square plus 2ab. Identity 2 is a minus b square is equals to a square minus 2ab plus b square, or a plus b square minus 2ab. This means that the square of the difference of 2 terms, square of first term plus the square of second term and minus 2 into first term into second term. Okay. This can be proved like this. Okay. Here a plus b, we multiply it. Here what will you do? You will multiply a minus b, right? Identity number 3 is a plus b, into a minus b is equals to a square minus b square, right? This means that first term plus second term into first term minus second term is equals to square of first term minus the square of second term. Okay. So, how are you going to prove this? Have a look. A plus b into a minus b, a minus b plus b, a minus b, a square minus ab plus ab minus b square, minus plus cancels out. So, a square minus b square. Okay. Okay. Now, let us do first example, 3x square plus 4y square. We will use your identities, 3x plus 4y square. Okay. This is a, this is b, and the identity is a plus b whole square is equals to a square plus b square plus 2ab. A is what? 3x square, b 4y square plus 2 into a 3x into b 4y. 3 square is 9x square, 4 square is 16y square plus 2 3s are 6, 6 4s are 24xy. Okay. See how simple is this to use the identity, right? Exercise 14.4. Use a suitable identity and find the products. X plus 4, x plus 4. X plus 4 square we can write, right? This is a plus b whole square. Now, we can use the identity. Identity is what? A plus b square is equals to a square plus b square plus 2ab, right? X square plus b is 4, 4 square plus 2 into x into 4. So, x square plus 16 plus 8x. This is the answer, right? Things to remember. The product of two monomials is the product of their coefficients and the literals in the two monomials. The exponent of each literal being the sum of its exponents in the given monomials. 2. To multiply a monomial by a binomial, we multiply the monomial with each term of the binomial and add the products. 3. To multiply two binomials, we multiply each term of one binomial with each term of the other and add the products. 4. To multiply a binomial and a trinomial, we multiply each term of the binomial with each term of the trinomials and add the products. And there are standard units for the value of a and b. Okay, so these are the identities. Do memorize these formulas. Okay, students. Now you will do practice of the remaining questions.